With great pleasure and honor, I would like to record you a message entitled Extraction, Isolation, Purification, and Structure Elucidation. Why? For drug discovery. I will tell you the whole story here that we start from any natural origin based on extraction, isolation, then we go for structure elucidation, hopefully our dream to find drug discovery. Let us see the whole story from the beginning. If you start from any natural resources available to you, the aim to find a drug. The world now is panic because of Corona. Why? They don't have drug for coronavirus. So if you are lucky, you can find a drug, like Nobel Prize, which we'll talk about it shortly. To do that, you must have be in teamwork of 5 groups. First, to go to ethnopharmacologist, which means that people use the traditional medicine by experience. Grandfather, mother, expert living with plants, which gains informations. Identification of the plant by botany, number 2. Number 3 is you, as a pharmacognosist or natural product, to do extraction, isolation, and structural elucidation, which is the title of the lecture. In guidance by bioassay. So the guidance is your pharmacologist who do the bioassay. For pharmacognosy, you can do it as well. Hopefully, you get potent active compound. This is a dream of all academics and as well as drug companies. At that stage, then the clinical trial will go to get a drug. Collection and preparation of plant material. So for sample collection, it can be the aerial parts or underground parts. And the first is identification by botanist to get what is the family, genus, and species. Then you start to collect the samples, dry it, or take it as a fresh. Collection of medicinal plants. We must avoid adulteration, and you can see details in this YouTube. So for each part, to make this lecture intensive and have the whole story from the beginning until the end, I give you, usually, I refer to YouTubes, which you can go and see the lab work, or more theoretical about this part, which I had been recorded at Uppsala University to help the students. Of course, you can also have this guidance by dictionary, by drugs of natural origin, as well as the 13 plants through this book. I know that you have both books to guide you as well. For avoid adulteration, adulteration means that if you have any mixed undesired substances with the plant material, or if you collected it in wrong season, or before it becomes fully grown, it means that not good. So this is what explained here, that growing season, to have the proper quality, and finally, the active constituent may be distributed in any part of the plant, and you will see examples. Botanist, to identify the plant and put it in, we have it in authentic Voyager sample. And then we start with the extraction. Extraction in very simple way, like you make tea or coffee. So you put the solid and then you have liquid, right? Then you get maceration or oxalate extraction. Another way, of course, liquid extraction. And in the companies, you can see by supercritical ultrasound accelerated solvent extraction. In very simple way, maceration, which means that you take the plant material, ground it to be fine powdered, then put it in a solvent by soaking. How you choose the solvent? According to polarity. You can get everything at once by using very polar solvent, methanol water. Then you do it at once, but then you get all of them in only one extract. You can do stepwise extraction according to polarity. Hexane followed by DCM, then methanol, water. It means that you get it according to increasing polarity. Whatever the way you soak the plant material, you make filtration. After filtration, you get the filtrate. This filtrate you evaporate, where you get crude extract. In some countries, you use crude extract directly. for treatment. And this we call it crude drug because you have mixture of about 100 compounds. But in this case, if you have like coronavirus or cancer, then the effect is much less because the active constituent is not very concentrated. If you need the active constituent to be very concentrated, then you do according to my literature, which is isolation, purification, identification. Another way of extraction, this nice photo, you see? You put the plant material here with solvent and heat it, and you would like to make it as a percolation, then you connect it with water. Then it will be extracted within few hours, right? The conclusion, extraction occurs before in isolation and purification. Extraction first. Second, solid liquid extraction before liquid extraction. Lowering particle size when it is very fine powder like tea, then you get efficient extraction. Solid liquid extraction depending on polarity, as we have seen. But what about liquid extraction? It is like depending on partition coefficient. Then the second is drying. How we dry our sample. In every step in extraction or isolation and purification, you need dryer because the solvent help you to get the compounds, but then you would like to get rid of it. Simple way is rotatory evaporator, like this. So you take your filtrate or the macerate, the one contains your extract, and then you put it in rotatory evaporator. Rotatory means rotation. Evaporator means it will evaporate the solvent. Then you end up with only the extract, like here. Second way is freeze dryer. It is the same idea, but you use much more stronger pump to evaporate it more quickly. And this depending on the boiling point. If you, for example, have water, boiling point 100, then you need freeze dryer, right? And for large amount, you need it. And the cooling here is much also colder. So it is about minus 20. Then you get dried extract or dried fraction. What about if you do HPLC and you have 61 tubes? Then you do it in 61 times here, or not very efficient. Then we have a speed vac, right? Which you can put all the tubes at once, and within few hours, you get all of them dried. Simple, right? Second step of your work after extraction, you have 100 compound. If you take it and work directly on it, it will be too much. So you can make like fractionation first. One way is liquid extraction, which means that you take water as aqueous layer with acyl acetate or DCM, then you mix together. It will be two-phase extraction or liquid. Another way, stepwise extraction, which means that you use SBE. And this is reversed phase. It means that I use very polar water to less polar is acetonitrile, to less polar is acetonitrile pure. Another more efficient way, because in this case, you don't see what exactly happened. If you would like to see what happened and you do more efficient fractionation, then we use FBLC. Why? Because in FBLC, you use a column. So this is first. So this is bigger column than SBE. Second, you have UV detector, which you can detect. Third, that you get it in 61 tubes. Here you get it only 3 fraction, and here is in 2. So from here to here is more efficient. Only 2, 3, 61 tubes, right? Then after that, you do further fractionation and purification. So our aim is to get the single compound pure. Then you achieve the first target from your work. Then you can use also from old fashion to new fashion. Old fashion, which is very cheaper, is column and cephatics. So the stationary phase, 2 words in chromatography. Stationary phase means the matrix. Mobile phase means the solvent you add. So you put the extract and you elute it with solvent, then it will make isolation, which you can detect by thin layer chromatography to see how many spots and how it look like. Another more efficient way is high performance liquid chromatography. That's why it goes from here, from very cheap to expensive one. Why this is very expensive? Because you use a strong pump. That's why you use also metal column. So this metal column can, you can use high pressure on it. It will not be broken. But here, if you use high pressure, it will be immediately broken and explode. And the analytical column, in order to see how it look like, and this takes about 1 hour. But if you use this one, it takes few days in order to do isolation and verification. So more efficient and also shorter time. However, sometimes is needed, of course. So we shouldn't forget all the fashion techniques as well. Then we go to the final step of your work, which is identification or structure elucidation. Now I get the pure compound, which is the first challenge. Second challenge is how to get the structure. If you would like to get the structure, then you use a spectroscopy from old to new, from cheap to expensive. It means that less powerful to much more powerful. So UV, in order to detect the class of compound or aliphatic or aromatic, IR, infrared, functional group, mass spectrometry, the molecular weight, then the fragmentation. That's why it's million. NMR to get everything about everything, every kind of proton and the carbon and how much it attached. This is 20,000, and this is about 20 million when it is 600. It means the information you get is much more. And here you can see Nobel Prizes because they make something very beneficial to the humanity. Without a structure, we cannot get the compound. We cannot get active drug. And also you could use X-ray for crystalline compound and with suitable dimensions. And here you can see the link for more details and the lab, which has been recorded at Uppsala University as well. Let us take some examples to apply this work. Now, one of you as a student, would you like, for example, to work with plant? Let us take examples from literature. This is a plant material. Now I can hear you. What is the first? Identification of the plant material. And before that, talking with Indian people using the plant in traditional medicine. Someone would like to find potent compound as antimicrobial because in 2030, it will be high resistance for antibiotic and many people will be dying. So I would like to get natural compound as antimicrobial. Then you go with talk to traditional healers. Can you provide me with some plants as antimicrobial? They say, yes, I recommend this plant. Immediately, first is botanist to identify. So two words means the species. Leaves means the part which contains a compound. And what is your dream? To get pure active compound. Like this case. Oh, they are very successful. They get pure active compound. How they get it? This is your work. Now we can take it easy. After starting your work from here until the end. Extraction, grounding first, extraction, filtration. Then after that, you work immediately with extract. Maybe it is inactive. If it is inactive, it means that you will lose time and the money and the energy. So your guide here must be the bioassay. That's why we call it bioassay guided isolation. Without the bioassay, no guidance for you. You will fail. So the meaning of bioassay guided isolation, which you must know about it, and in every exam, it must include the meaning of bioassay guided isolation, because without it, you cannot find the drug. So if this extract is active as antimicrobial, now I'm very happy, because the traditional healer gave me correct information, which I proved in the lab. So it showed antimicrobial, I'm happy. Then the second step, what you are going to do after extraction, fractionation. Here's, for example, they use column chromatography according to increasing polarity. Now it comes the exciting step. Which fraction is active? We have 7. Should I work with the 7? No. Again, your guide. Who is your guide? Antimicrobial activity. If antimicrobial activity give only 2 is active, then, oh, I'm very happy. Why? Because it means I have active compound in a specific refraction. It is not a spread. Now I don't work at all on 5, but I work only on the active one. I think it is easy now, and you can see it more easier here. Make extraction by hexane, ethyl acetate, equals ethanol, according to increasing polarity. Which one you are going to work? Who is your guide? Bioassay, which is antimicrobial. Oh, this is active. I'm very happy. I make fractionation. Which fraction is active? 6 and 7. Oh, very happy again. I do more work in order to get the compound pure. So extraction, isolation, purification to get the compound, the whole story. Then spectroscopy to get the structure, which is steroidal glycoside with this activity. Now you finished your work and you make a party. I would like to talk more about ethnopharmacology, how they can discover artemisinin, which got Nobel Prize, and you feel proud because you are Swedish. In Sweden, this is the most prestigious and the most the top prize regarding money and prestigious. Why they gave her Nobel Prize? Because she got artemisinin, which is anti-malarial drug. I hope you too. And how she did that? Because they see the plant is used in traditional medicine as anti-malarial. So this is the key point, right? Again, with Hypericum perforatum, it is against depression. Then they get it as antidepressive agent. And you can see more in this link. So for this Artemis plant, it has been used in Asian and European long time ago as treatment of malaria, cough, and cold. And then they isolated and structurally elucidate. So this is your work. Is extraction, isolation, structure elucidation to get this compound, which is anti-malarial drug. Now we are going to some work from my students in the lab at Uppsala University to give you an idea. So we'll talk about marine, cyanobacteria, bacteria, plant, so different kind of organisms to see the whole story from the beginning until its end, right? And all has same ideas with some differences, which we will deal it this way. If we take, like example, cyanobacteria, marine resources. So now I can hear you. First, to collect the marine based on observation. After collection, extraction, isolation and purification, structure elucidation, and don't forget who will guide you, bioassay. So when we started this sample, we take this marine sample and we ground it, we freeze dried it, because when you get it, we get it, by the way, in ethanol to keep it so it doesn't, nothing could happen to it. So this ethanol will extract some of it, which you will take and evaporate. So this is part of it. What about the others? We do freeze dryer. Why? In order to ground it, as we agreed. Then extraction by shaking. Now I can hear you. After shaking, filtration, then evaporization, then you get the extract. So you get the extract, which is mixture of so many compounds. What are you going to do? Stepwise extraction or fractionation by SVE using high polar water till less polar acetonitrile. After that, you can make FBLC. And from FBLC, you can collect more fractions like this case. The first tubes doesn't contain anything. Then it comes, these are similar tubes to collect together. These are similar and the same until the end. Then we take it and do HBLC in preparative. So this is a peak, another peak. And this is the relation between time and the relative abundance, which means concentration. So each peak of this is have different retention times than the other one. And this is another example of purification by HPLC. You can see how many peaks. And this is UV, which means that you have important compounds here. Here, no compound, no peak, and no yellow color. I think it's fun and exciting. Yes, until the student gets this pure compound, then she is very happy. Why? Because this is the NMR, which is a structure elucidation. I will not go to details. You can go to the other links for that. But very briefly, that from 0 to 6.2 aliphatic region, 6.2 until 8.5 aromatic region. After that is the functional group, right? And this is what you can see here if you follow these numbers. So the numbers here is aliphatic here. And then the aromatic 16 or double bond, right? Functional group of OH is here as well. Now we can go to another example, which is plant, who is cyanobacteria from Japan. And this is by Johan. He did a fantastic job, right? As well as every student, of course, right? Why we take this one? Because the ocean is an important source for future lead compounds. And it has been a very long history. And you can find it in environment like polar ices, hot springs, etc. Right? So this is in USCA, for example. For our samples, this has been collected. We collected it from Japan, from this area. And this is the cyanobacteria, how it look like. I took the chance when I teach the course there in the December 2007, 2018, and I got this sample for Johan, and he started to do extraction. You can use different way, methanol directly, for example. It means I got everything because it is already also contain water. So it means I do extraction by methanol water, which you got everything by methanol. This is very fine. Then you do partition between what? Ethyl acetate and water. Why? Because they are immiscible. Then you get water layer and the ethyl acetate layer, which you can do further fractionation by hexane methanol. Now you have in total 3 extracts: water, methanol, hexane. Which one you are going to work? I hear you. Do I say first? And if this is active, you go further for this one. And this what happened. They go further to do purification until they ended with active compound. And this is HBLC, which is, it looks very nice because very good separation. Even it contains so many compounds. And this is a mass spectrometry as well, right? Another way for identification of compounds in mixture, but this in case of non-compounds, you can use database. And this is very nice because you can work from home. And this is why I say for you as young students, you will be better than me because you get all my experience and you have very fancy techniques now, which is databases, which we must compile it as new technique with also all the techniques. So for matches of the library, then the student could suggest that we have these compounds in the extract. Additionally, he do further work by isolation, purification, structure, elucidation, and he got biodiversity of compounds, as you can see from this. Now we go to another target, which is plant material. For this plant material, now, you know very well, extraction, isolation, then purification and structure elucidation. But why I put here before purification, LCMS and NMR? Now I'm tricking you. Why I do that? Yes, this is again new technique, which is dereplication method. As I told you before, the bioassay could guide you to work on some fraction, not the others. This is again another guide. This LCMS and NMR, it is early identification, early guidance for targeted compounds. And we have the experience to interpret the data. So we can see if this fraction, for example, like what SIDA got about only fatty acids or glyceride fatty acid, then we don't need to work on the fractions and to lose time, energy, and the money because we already know it. So if we do it earlier, it helps you for the next step of fractionation and verification. And that's why I put you this example, because you will see that from NMR, we have sugar in and the aliphatic region, as I told you before, and you have aromatic. Now I'm targeting this compound. Why I'm targeting this compound? Because the bioactivity says that I have flavonoid glycoside. And this, I need this class of compound. So I will target it. This is, by the way, is the mass spectrometry, which is relation between time and relative abundance. And this is a molecular weight. right? So you have molecular weight, etc. Very, very, in very brief way. We targeted this compound. We did further analysis by LCMS, and then purification by HPLC, which is very nice resolution as a compound here, compound here. Why resolution is good? Because there is difference between retention time here and the retention time here until further purification. Oh, now the student is very happy again because she got the compound pure. As you can see from the NMR, you have only the peaks which is assigned for aromatic region, as you know, and the functional group as well. So here is flavonoid glycosides, as you can see. I will tell you another story which also you will be happy about it, about Origina maritama. Here it started the story. Can you say something about this slide? This man is extremely important. That's why we make this trip to Egypt, to Sinai. I would say this man better than 1,000 of me, because me is academic and my knowledge will be published in the paper, but his knowledge is in his head. He got this knowledge about these plants and used in traditional medicine from grandfather and the father, etc. But his children may be not interested. That's why we get this idea to open a school to learn and teach students about uses of plants in traditional medicine. We make this trip with Karolinska and Ulf. At that time, he is young, and he is still young, of course. With Karolinska and the KTH and the group of students in global pharmacy course. So we get his knowledges about these plants and we get the plants. Look what happened. We published the work based on his knowledge. That's why we call it traditional medical uses and the cytotoxic activity. He recommended plants for cytotoxic activity of 61 Egyptian plants. So give us 61 Egyptian plants, but he recommended some only of them as cytotoxic. Then we must go to the lab and see, do we have scientific evidence? Then we can publish paper in Q1 Drug Discovery, which is Journal of Ethnopharmacology in this case. Then discovery of an active cardiac glycoside from Origina maritama. It means we will get the active compound. That's why it is successfully published. I even included him in the paper because he gave us valuable knowledge. So we must be honest, right? And fair, right? And of course, it is a teamwork between chemist or pharmacognosy, pharmacology, medical doctor, and the botany, as well as Ulf, of course, with excellent contribution. And here you can see the scientific evidence. So this is the plant is recommended by him. It is really active. This is the plant is, he said it is inactive. So the biology assay matches with his experience. That's why we have him in the paper, right? So we followed the activity of Origina maritama until we get the pure compound. And this is the active compound, and we get the IC50 value. So now we are very happy that we could end up with the final results of the activity, right? Now I can take another story, which is about bacteria culture. What is the aim here of one of the students? So our aim here is the lipopeptide. Why we call it lipopeptide? Lipo means it contains hydrocarbon part, which is not polar. Peptide because it contains peptide bond. You see, this is peptide bond or amino acid. This is again. So it contains non-polar part and also another polar part, right? And that's why the definition of lipopeptide are surfactants of both peptides and fatty acid. So it is new idea, and I will show you nice. So how to make bacteria culture? Very easy. Immense the bacteria at minus 80 in 50 milli of media and let it gross. After 24 hours, it will be gross. Do I need the bacteria or the compounds from bacteria? I need the compounds from bacteria. So I will make centrifuge to get the supernatant. So the supernatant is the one containing the active compound for me. Now I have tricky to add two normal HCl. Why? That's why I put this idea. Because it contain here NH. So this is alkaloidal function. So this alkaloid, if you add HCl, it will react it. It means that the HCl will catch it all lipopeptide. Now you think in a smart way to only target the classes so you can play around when you have the extract. Now you know why I gave you this example as well. Then you make incubation and you adopt it with the lipopeptide after evaporization in the same way. I think you know it quite well. Then you go further for structure elucidation. And this, if you would like to know it in large scale, we use the large scale up to 2 or 3 liters to prepare the media. In this way is very easy. And again, SBE, I will not go to details, but I will show you also that we use the same technique of FBLC. And furthermore, I will give you very briefly the mass spectrometry and why it is exciting. After we did this reaction, is this contain really lipopeptide, which is molecular weight around 1,000? Yes. So this is a mass spectrometry relation between M over Z and relative abundance. So the molecular weight 1036, 1022, etc. It means I have lipopeptide. So we were very happy and we continued the work. And further purification by HPLC. Oh, now we are very glad, right? Because we get the compound pure from HPLC, then we go to the mass spectrometry, and we are lucky that we have the experience also, and by calculation to see the first is the molecular weight of the compound. What about next week is after fragmentation. So when you break it, the part which is get off, you get rid of it, you get the remaining only in the molecular weight. And this is how you interpret the data in this way. So the first is the molecular weight. If you lose something, it goes out. Then you get the remaining. Lose one part, you get the remaining until you get the small one. Of course, the supervisor help you all the time. So don't be worried. We start with every student from scratch. He just get the knowledge and the basics from these lectures and from corresponding YouTubes, then come to the lab to work. And he can work even from home to interpret the NMR. Every student say, oh, it will be very difficult. I told him, no, it is very easy. Just learn the basics and we help you and you will find it by yourself. I will end the lecture with some questions regarding polarity. So we can practice together. If this long chain acid, what do you expect? It will be non-polar to medium because this long chain, only one carboxylic group, this makes it until low to medium. The same here. If no carboxylic group at all, it will be definitely non-polar. Then you need hexane to extract it. What about lipopeptide? This part non-polar. And now comes the polarity here. Then it is medium. Then you extract it with medium solvent, like ethyl acetate, for example. The same here. And the same here, you can practice. What about if you have peptide? No, peptide, you have a peptide bond, carboxylic group, and NH2. And you don't have long chain aliphatic. It means it's very polar. So you must use acetonitrile water, for example, which is polar. And the same with here. What about beta-cytosterol? It is much less because no acidic group. So, and it is also mostly hydrocarbon, then it is non-polar. What about flavonoid glycoside? Several hydroxy groups, many hydroxy groups, then it is polar. I give you the answers in the next slide, which you can also don't memorize anything. Look to everything, and by thinking, you will understand it. Hexane, why it is non-polar solvent? It is just CH3, CH2, 4 CH3. So there is no functional group, no OH, non-polar. Benzene, non-polar. Toluene, benzene ring with CH3. So please write every structure in front of you. And then it is, you can say non-polar or no. What about if you go to DCM, CH2Cl2, now you have halogen. So it started to be medium. What about chloroform? Same. Diethyl ether, oxygen in the middle. Ethyl acetate, C double bond OO in the middle. Acetone, CO in the middle. When the oxygen is in the middle, it is medium. What about if methanol? It is OH in the end. Ethanol, OH in the end. Acetonitrile, CN in the end. Water, OH in the end. So when you have the functional group in the end, then it is polar. I think it is easy now. And then it will dissolve the corresponding compound. The final, just to give you very briefly about our interest and application of bee product. We are very much interested about the bee product, not only because it is healthy and cosmetics, etc., but from the point also of drug discovery. I think it has important um, activity as well. That's why. And it is not only honey, it is also bee venom, it is bee wax, propolis, royal jelly, which is very, very expensive. And from this, we have been found out and we published interesting work that it has even neurological action. And it has also very important activity in chemistry and pharmacology. That's why we publish it in very high impact, unusual. Usually we publish in impact factor about 3, 4. If it is more than 5, is excellent. If it is more than 10, very unusual. So this is in more than 10. With this one, I would like to really thank you so much. And I must remind myself and you, usually collaboration. So your collaboration with me to follow this lecture will help us also that you understand the course. So all the time we need to be collaborated. Now you can see the teamwork. Through this teamwork, they got Nobel Prize. It doesn't matter the color, the gender, the religion, etc. But all have one aim. With this, I would like to thank you with this very beautiful nature in Sweden, as well as the long history of Egypt. Thank you very much for your kind attention. And I wish you a very successful course. I am sure you will do an excellent job and you will enjoy the course. Definitely, if you are here physically, you will enjoy more with the lab and with meeting you. But we will do our best to understand the course and to enjoy as it happens with previous students. Thank you. هشام El-Seedi.